We have this question 5. One of the root of the equations, okay, is twice the other roots. Show that 2q squared minus 9rp equal to 0. So let's quickly go that. Let's solve that questions. Then after that, we'll come back to the second, the number 50 question. Okay. So what we do here is that question 4 solution. So suppose the roots are alpha and 2 alpha, because they say that one of the roots of the equation is twice the other. Okay, so that means we're going to have alpha and what? And 2 alpha. Okay, so next step, let's find the sum. Sum of those two roots, that will be 2 plus, that will be alpha plus 2 alpha equal to, that will be minus q. B is q. Okay, and then my a is what? P. So P. Okay, and that will be equal to 3 alpha equal to minus this over P. Then alpha will be equal to what? Divide both sides by 3. Then alpha is equal to minus q over 3p. Okay, so let's get the product of the roots, which will be equal to alpha times 2 products equal to c, that's c over a. My c is what? R, and then my a is what? P. Okay, so this will be equal to 2 alpha squared equal to R over P. Okay, so what I can do now, you call this one 1, call this one 2. So plug in 1 into 2. Plug in 1 into 2. So you now have 2 into brackets minus q over 3p squared equal to r over p. And that will be equal to 2 times q squared over 9p squared equal to r over what? R over p. Okay, so if you cross multiply, then you have 2pq squared equal to 9p squared r. Okay, so therefore p is here, you can cancel out, p is also here, so that will be 2q squared. Okay, and here that will be 9, that minus 9pr equal to 0. So we've done what is required of us. We've done what we are told to do. Okay, so that's just that on this question. Let me quickly recap it. Some of the roots, we know that one of the root is twice the other one. So the root will just be alpha and 2 alpha. Okay, so sum, that will be alpha plus 2 alpha equal to minus b q over p. So that's this. Then alpha plus beta, that's 3 alpha. Then make alpha will be here. Divide both sides by 3. Then you have this called equation 1. For the product, you have this one times this one, that's 2 alpha squared equal to r over p. Okay, so plug in this one into 2. Okay, because this one is linear, so plug this one into 2. Then you have 2 into bracket. Your alpha squared will be this. Okay, equal to r over p. Then this will be equal to, if you square this, that will be q squared, and this will be 9p squared. Okay, then you can cross multiply. So this one will go this way, because here you have 2q squared over 9p squared. So cross multiply, that will be equal to 2p q squared equal to 9p squared times r. That will be 9p squared over r. So then you can, p is here, 2 of that of p is here, so you can slash. So it will go here, to make 1 here, and move this one to other side. Then that's done. Okay, then question 5. Question 5, one of the roots is twice the square of the other. Show that this is, show that that's. Okay, So in that case also, it's similar to what we just did here. Okay, it's similar. So what we just have to do, uh, suppose the roots are, that's question 5. Question 5. So one of the roots, okay, that's alpha, is what? Is twice square. So that will be this alpha and alpha square. So one of the root is twice the square of the other. Okay. There's a repetition here of the other. Okay. So yeah. So that's just that. That's the root. That will be alpha and alpha square. So let's get the sum of the sum will be equal to alpha plus alpha square equal to sum of the root will be equal to what? Minus b over a, and that's equal to what? B is minus p, so that becomes p over what? Over 1. So that's p. That's p. You can call that one probably equation 1. Just note it. Then the other one, the product. We have alpha times alpha square equal to, for the product, that's c over a. Now that will be q. That will be q over 1. So that's q. So we have that. That's q. Okay. Yeah, that's q. And this will now become alpha cube over equal to q. Okay. So what we now do, it will be more convenient. It will be more convenient for what you are supposed to show. You can see you have P3 here. Okay, you have P3 there. Okay, so that's an indication that P3, what you have to do to that equation 1 is to cube equation 1. Take what? Take the cube of this equation. Take the cube of that. So that, because from where we are supposed to show, we can see p power 3 here. So then that will now become alpha plus alpha square cube equal to what? P3. Okay, equal to P3. And that will be equal to, I'm going to use binomial expansion. I really like so that will be equal to alpha 3 binomial expansion plus 3 combination 1. This one will be reducing power 2, and this one will be coming up alpha square power 1. Okay, then 3 combination 2, this will be reducing alpha, and then this will be increasing alpha square power 2. And finally, this will be alpha square power 3 equal to what? Equal to P3. Okay, so that will be equal to alpha 3 plus 3 combination 1 is 3, alpha square times alpha square, that's alpha 4, alpha power 4. Then 3 combination 2 is also 3. This is 2 times 2, alpha 4, and this one alpha to the power 5. Okay, then plus 2 times 3 here, 2 times 3, that's 6, that's alpha 6 equal to what? P3. Okay, so let's see what we can do here so that we can also make use of this equation. So can make use of that equation. Alpha 3. You can see alpha 3 is here. That's q. Yeah, plus these two. Can we factorize it? 3 is common. Then actually alpha 4 is here, alpha 5 is here. So alpha to power 4 can be factorized, but we will not do that. We'll make it alpha to power 3. It's useful. Make it alpha to power 3. Okay. Yeah. So, and that will be equal to just make 1 alpha here. Make 1 alpha there. And then it will remain how many here? Plus alpha 2 here. Okay. Then plus this alpha to the power 6 will be here. That will be q squared. Q squared equal to what? P3. Okay. So the thing is forming. So we have q plus 3. This is what 3, alpha to the power 3 is a q. 3q, then 3q, they just relax, 3q into this one, alpha plus alpha square, that's p, that's p, that's p, plus what? Plus q square equal to p3. Okay, so let's move this left hand side to the other side, and that will be equal to p3 minus and be looking at what we have here, minus 3qp. Okay, what again? Then minus q, okay, minus q. Then you have your q square being isolated, minus q square equal to 0. Okay, so finally p3 minus, take a check here, 30. Okay, qz, take your q out, then you have 3p minus times minus, that's plus 1 minus q square equal to 0. So that's just that, and that has been proved. We've shown that that's been proved.